that is for whole container system. For stationary container system, you see this snap is taken from Google Map, and maybe some of you may identify the area. This is Dhanmondi, near our campus, near Shukrabad campus. If you remember, this is near. This is very near to our Russell Square, Dhanmondi 32. Okay. So generally, we have an area from where we have to collect the solid waste materials. They have a layout of roads like this one, or maybe like that one. So what we have to do when we have to plan the routes, we have to plan carefully so that we don't have to run through the same road twice. Because if we have to run through a same road twice or thrice without collecting any waste, that means we are wasting our fuel and we are wasting our time. Okay, in that way, your workers are inefficient. So what we do, we generally make a map like this one, and what we do, for example, in this block, in this box, we have many buildings, and in each building we have many families. So we have to count the number of the families and then write down the numbers like this one. Okay, I will show you later. Okay, this is the presentation file, so I should go back to PDF file where I can write on it without much trouble, because when I write on presentation file, it sometimes create problems. So let me write down on it. Okay, next thing is we have to make a map like this, and if you look carefully, say for example, in this block there are many houses, and the people responsible for collecting waste should know how many families are living in this house. Maybe this is a 10-story, maybe this is a 6-story house with 12 families. Okay, there are 12 families. Maybe here 16 families are living here. Maybe here 20 families are living here. Maybe here 6 families living here. So all the numbers, and maybe for this home, the collection gate was here, not in this side, maybe in this side. Okay, so maybe 20 families are living in this house. So total for this row is, just add them, 20 plus 16, 36, 48, 54, 62 and 82. So total 82 number of families are living here, 82 families, okay, in this side. Similarly, if you count the numbers of the families in this side, that may be 75. And the collection maybe in this side, maybe only one, maybe 12 families only. Maybe one building here, only 12 families, and maybe here only one building, maybe 10 families. So we have to write them down. The 12 families are disposing waste here, 82 families disposing waste here, and 75 families. So then we have to plan the truck route or our collection vehicle route. Okay, so finally the map will look like this. Waste collection map will look like this. How many? These are the roads where we can drive our vehicle. And in Bangladesh, we have left-hand side driving. So this way go and this way coming back. If the road is very narrow, one operator can collect waste from both sides when driving through this road. But if it is a wide road, or if the collection vehicle have mechanical arm, that means robotic arm, to collect waste from only one side of the road, then to collect the 15 family households road, you have to go in this way, and you have to again come back in this way. You cannot collect in one trip. You have to go and come back to collect the roads materials from this side. So there is a problem, mathematical problem here regarding this map. Maybe similar this map. Yes, no, this map. It says there is a layout the collection routes for the residential area shown in accompanying figure. Assume the following data are applicable. You see, Now, what are the data? Occupants per resident. That means these are the number of residents. That means 6 families are living in here. So each family have 3.5 members. So 6 families must have 21 members. 21 people are living in this zone. That means we have to collect waste of 21 people from this side. Here 12 families are living. So each family have 3.5 members. That means 42 people are, we have to collect waste of 42 people from this side. Okay, things are like that. So what first thing we have to do is to count the number of total families and count the total number of people. Okay, let us go back to the question again. Occupants per resident 3.5. That means each family have 3.5 people on an average, because people cannot be fractioned. But if you divide the number of people divided by the number of families, the result is 3.5. So this is a good data. This can be used. Solid waste generation rate 1.6 kg per person per day. Each day, each person produces 1.6 kg. So when you're looking at it, you might be thinking, what should be the data in Bangladesh? Generally in Dhaka, this value is 0.5 kg per person per day. Okay, each person in Dhaka produces this amount of waste. So far I know. This data might be from America or other countries. So collection frequency, it is not given. This should be weekly. Not daily or weekly. So we cannot decide it right now. Okay, we don't know if should we collect waste each day, or should we collect waste once in a week, or should we collect waste once in 2 weeks. We actually don't know before knowing the total amount of waste produced by this area. Okay, let us see. Type of collection service, curbside collection. That means stationary container system, curbside collection. Collection crew size 1 person. That means the truck driven by only 1 person. One truck, one collection vehicle, maybe something like this, and only 1 person driving it. So it can have a mechanical arm or something like that. Collection vehicle capacity is 20 meter cube. Now this is the critical data we want to know. Compact density of solid waste 325 kg per meter cube. That means 20 meter cube waste means 325 kg. It can hold this amount of waste. Now how much waste is produced, that we have to calculate, and then we can determine how many trips are required. Okay, so there are some constraints. You cannot make a U-turn on any route. That means when you are going through a road, when you are collecting waste from these points and these points, you cannot just turn the truck and then come back. Then how can you collect the waste from here? You can go there, maybe here is an intersection. You have to go there, and then you can come here, something like that. But you cannot make a U-turn, because U-turn takes a lot of time. So this is the constraint, that you cannot make U-turn. Maybe there is not enough space to make a U-turn. Collection from each side of the street with a stand-up right-hand drive collection vehicle. That means from one side, this is not very clear, but I am taking that they can collect from only one side, because only one person is involved. So this is not possible to collect from both sides. If the streets are very narrow, and maybe this person have 2 helpers, like 2 persons are hanging around here with the car, and one is collecting from this side, another is collecting from that side. In that way they can collect from both sides. But because only one person is driving a car, probably this is from only one side of the road. So how do we solve the problem? First, we have to calculate how much waste is produced, and then compare the amount of waste with the capacity of the truck. Then we will know how many trips are required each day or each week. We don't know should it be day or week. So this is the map. You can see that in this block, so we have to calculate how many families are here. So it is very easy, because there are similar blocks. So this block was 6, 6, 12, and 16 families living in this block. Okay, 16 families. So 16, 16, 16, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 blocks with 16 families. We have, this is 12, 12, 6, 36 families living here. So 36, 1, 2, 3, 4. 4 with 36 people, and this is 12, 12, 24, 28. 1 with 28 people. So this calculation is shown here. 10 blocks with 16 people plus 4 blocks with 36 people and 1 block with 28 people. Total 332 families, residences, 332 homes. So in 332 homes, how many people are living? 332 homes into 3.5% per residence. This is the total number of people living here, and each people is producing 1.6 kilogram of waste. So if we multiply these three values, we will get the total amount of waste in kilograms each day. Kg per day. Total amount of waste in kg per day if we multiple these three values. But they found that the density each day, the amount of waste is too insignificant to fill out the truck size mentioned. The truck size was 20 meter cube, but each day they produce only, if you just let us check, 332 into 3.5 into 1.6 kg. How much is that? $332 multiplied by 3.5 into 1.6. So this is 1859 kg, 1859.2 kg, and that means 1859.2 divided by, because the density was 325 kg per meter cube, 325 kg per meter cube. That how many? This is kg. So if we divide it by 325 kg per meter cube, we will get a meter cube. That means volume. And what is the volume then? Divided by 325. You can see the volume is 5.72 meter cube. 5.72 meter cube volume is produced in each day. This is the volume of waste produced in each day. So what they did, they go for 7 days. That means weekly production. So when they calculate the weekly, how much waste is produced in 7 days, and if you multiply it by 7, it becomes 535 749. You can see this is 7 into 5.72. Around 50 meter cube per week. So 40. Sorry, I'm sorry. This should be 40. 40.04 if I multiply it directly. So they went for weekly production of solid waste in volume per week. We can go for volume per day as well, no problem. But you see, if we go for volume per day, we have to discard that amount because this is even less than the truck size, one truck size. So we don't need a truck each day. So let us go for weekly collection frequency. That is why they have collected the amount of waste produced in 1 week, and it is 40 meter cube per week. And then we need only 2 trips because the collection vehicle size is 20 meter cube. Now we have 332 families here. So if we make 2 trips, that means 1 trip will cover half of them. Half of them is 166 families. So now you get, for each trip you have to touch 166 families house, 166 residences. Well, knowing that, you have to divide them into 166 and 166. But unfortunately, if you consider the blocks, you can see it cannot, no blocks, any combination, no combination can make 2 equal division. you have to divide it by 164, 168. That means this is 2 more, 2 less. And if you can divide like the provided in the book, this is also 168, 164. Root 1, you can see what they have done. Their collection is this one, this one, this one, this one, this one. This is the first root. 1, 2, 2, 2, 2, 2, 2, 2, 2, 2. So this is their first group, and another one is this group. No, this one. These are another group. So they are collecting their waste from these blocks in one trip. Another trip they are collecting from these blocks. But even though they divided it by this way, they also had 168, 162. That means 166 was the half. So 2 more, 2 less. But for our mathematical problem, I found it very difficult to follow the original graph or original driving scheme provided by the book. This is the scan copy from the book, because in America they drive on the opposite side of the road, right? Okay, what we do in Bangladesh, we have a keep to the left system, right? Hey, what is it about? What is the driving system in Somalia? Left-hand drive or right-hand drive?
Right.
Is it similar to Bangladesh or different?
Sir, more similar.
Similar. So
Yes,
this is the system we follow in Bangladesh and in the British region actually, but in America and American region they follow different rule. They drive on the right side of the road, okay, like this one. So this is called keep to the left. After we keep our vehicle on the left side, and there are very interesting stories why which one is better. Both parties have their own stories and own reasoning. This side is better. Why? Because they said initially there were horse carts. There were 4 horses. In horse carts there are 4 horses and a carriage. So the carriage driver used to sit here, or they used to sit, and their whip, they had their whip on their right hand, and their left hand was free. So when they cross one vehicle, they can exchange they could shake their hands with the left hand. So they prefer to drive on the right side. So this way they could shake their hands. But somebody said no, it was about the fighting of 2 horse riders. One horse rider is going in this way, another horse rider is going this way with a very long spear on his right hand. So he could hit the other person if he is on the right side. So this is the correct way of moving in the road. But others said no, in the road you are not fighting, you are greeting people. So these are 2 stories for why left hand side and right hand side. They're very funny stories. I don't believe any of them. Okay. So anyway, what I know, what the British did, because Americans have to do it in the other way. If they say it is right, Americans have to say it left. This is to secure their business, probably. Probably the business is one of the reasons. What do you think? Anyway, this.
sir.
Okay. Yes.
Sir, it's funny how the Greeks
Okay,
are fighting.
you can search in the Google or internet, left hand side and right hand side. Why? You can find this story. Okay, so they in the American, this is an American book. So their driving pattern is on the right hand side. So they when they drive, this is the road. This is actually the road. This is the road. Okay, this is the road. So they keep on the they drive on the right side. So all they close to the right side. So when they drive here, they collect these 12 locations, 12 residences west from different locations. 2 locations here, maybe 6 here, 6 here. So they drive like this and collect all the things. And you can see there are lines with dashed line. That means when they dash line, that means they are driving through this road, but they are not collecting any waste. But when there is solid line, that means they are collecting waste. So when they are collecting in this, driving this, they are collecting from this side actually, because they are right hand side driving. But for drawing purpose, they draw it in the middle of the road, because the road is here. But when they actually driving like this one, but to separate the lines, they draw it in the middle, but they are actually driving on the right. So you can see this is the driving pattern, and they know from where they are coming, their car, and from where they are going out. They are going out from this point to disposal side, from this side. So what I did, I tried to do the same problem, mathematical problem, but solve it with left hand side driving. So what I did is my initial trial was something like this. I divided just this left side community and right side community, and interestingly, this is also 164 and 168 like they did. Even though their division is quite interesting, because their division was like this. This group is a group, and rest of them another group. But I could divide them straightforward, just half of this area and half of this area. Then I planned a route. Initially, the car will come from this point, go and collect. And second time when it is going, it will collect, because they will not collect in the first time, because then they have to carry this load all the way without any good reason, because they are coming back here again. So this dotted line means they are driving through the road, but they are not collecting. The solid line means they are collecting. So this was my first solution. But the problem is, you can see there are many dotted lines. That means they have to drive in some areas where they are not collecting. That means they are wasting time and fuel. Second thing is, in the second route, it starts from here and ends up here. They are entering this area from this road or from this road, and they are exiting this area from this road, from that road. So I started to thinking a lot and find out a way to make this thing more efficient. If we have 2 blocks, we have same entry and exit point. Road can be like this, and in that way we don't have to travel twice in a road. If the blocks are like this can be so there is no exit point here. So maybe you are coming in this area from this road, so just start from here, okay? And after going through all the road, you have to go out in this way, okay? Or maybe, okay, no sir, I am not coming from this way. My disposal site is in this way. You can say, okay, you are coming here, and you can start right from here, and when you finish, you can go out from this way. Or if you want, when you are coming, you can start from this point, and when you are going out, you can just go out this way, because this is coming after this. You cover everything. At the end, you will come here. So this type of planning is continuous planning. This type of planning, we have some limitations, but this kind of planning, you can choose any entry or exit point. So these were some solutions I thought of, and then I applied it here. And you can see the entry and exit points are the same. You can make, if you choose, no, this is not entry point, this is my entry point, sir. So okay, you just drop this thing. You just make it a continuous line like this one, and divide it here. When you come, you can start collecting waste, and when you go, you can go back like this one. Just divide it here, okay? So in that way, this is a very efficient way. But look at the difference of the route. In no road, I have to travel or drive 2 times. In each road, when I travel, I collect. And in any road, I am not traveling twice. Can you notice the difference? No wastage of time or fuel. And here, we had some wastage. Here wastage, and here we have to drive, but we are not collecting. That means we are driving it just to turn the vehicle. So this is a very painstaking work, and if in one locality, maybe you have 2 trucks, and 2 trucks make maybe 4 and 4, 8 trips each day. For each truck, for each trip, you have to make a map or collection plan like this. So whenever you have a new driver, you don't have to tell him anything. Just give him the map. You are going to trip number 3. So this is the route for 3. You just abide by the map and drive like this. You don't have to think about anything else. And in that way, that person will be also efficiently collect the waste. Otherwise, a person that doesn't know the roads maybe go back and forth in the same road again and again, but will not collect efficiently. কি বলছি বুঝতে পারছো? Could you understand what I'm talking about? যদি একটা এলাকায় এরকম মানচিত্র করতে হয়, তাহলে খুব ভালো করে করা উচিত, যাতে নতুন একজন ওয়ার্কার যখন জয়েন করবে, সেও এসে জাস্ট দেখতে পারবে, ও আচ্ছা আমি আজকে যাচ্ছি কোন জায়গায়, অমুক পাড়ায় যাচ্ছি, এই হচ্ছে আমার রুট ম্যাপ, আমি ওই বাসাটা থেকে আজকে নেব না, অন্য গাড়ি নেবে, ঠিক আছে, যদি কাছাকাছি আরেকটা জায়গা থাকে। কারণ এই রুট ম্যাপ না দিলে যে অনেকদিন ধরে কালেক্ট করতেছে তার সমস্যা নেই, সে জানে কোন কোন বাসা থেকে সে কালেক্ট করে, কিন্তু যে নতুন আসবে সে জানবে না, সেই জন্য রুট ম্যাপ দরকার প্রত্যেকটা ট্রিপের জন্য। ফর এক্সাম্পল, একটা এলাকায় যদি এরকম 9টা গাড়ি থাকে, 9টা গাড়ি প্রতিদিন বাইর হয় এবং এক একটা গাড়ি 3টা করে ট্রিপ দেয়, তাহলে 27টা ট্রিপ, 27টা ট্রিপের জন্য 27টা ম্যাপ থাকবে, এরকম 27টা রুট ম্যাপ। ওকে,
জি স্যার।
Okay, in this way, nobody can tell, sir, আমি তো পথ হারাই ফেলছিলাম, sir, I lost my way. Nobody can tell you, and nobody can. This should be efficient, okay? But sometimes in Bangladesh, things are sometimes quite different, because sometimes they are driving, but the road is under maintenance work. Nobody knows. Then they have to change the route, and in that day, for that particular route, things will be different, okay? But in general, this is a good thing that we have a route plan for each car, like a bus route plan. Okay, thank you very much. Do you have any questions about this matter? You can ask me right now. So this problem might not be included in the midterm exam. This might I push it in the final exam.
স্যার মিড কয় তারিখ থেকে হতে পারে?
এটা তো